Hello everyone, I'm Zach Erickson. I am a graduate student at Caltech working primarily with Andy Thompson. And I guess I want to kind of talk a little bit about how physical oceanography can impact export. So export isn't on the title, but it kind of goes along with everything I'm doing. And we talked earlier today about how whether or not physics kind of dominates the ecosystem composition and how it probably doesn't. And I think in terms of export, people often think of export as primarily biological, sinking of aggregates and things like that. And I'd like to convince you that there might be a physical component to this through subduction, primarily at small scales, through various instabilities. So I am using a data set that is 1 year in a very small region of the Northeast Atlantic. And what you see is that there's a very strong spring bloom in that area, but there's also an increase in kind of aggregate amount of stuff in the water backscattered material over the upper 500 meters if you integrate it over the winter. And that's a little bit more confusing to understand. And I'd like to kind of think about that in terms of submesoscale instabilities that we can quantify in a parameterized sense and how these might impact water getting kind of pushed down out of the surface ocean through subduction, physical subduction. And so I'm going to take some physical data and decompose it into different types of instabilities, symmetric and baroclinic instabilities, and find that both of these can occur primarily in winter in this specific region of the ocean. And then I'm kind of thinking about how to deal with the global ocean and when do we see submesoscale instabilities kind of happening at the same time as production is happening. And when those two overlap, then that's a time when you might have a lot of export via physical subduction rather than export via aggregation and sinking. So come talk to my poster later, and I'll tell you more about it.